Okay. So good morning to all. So hope I'm audible as well as visible for the online students also. Right. So today we'll try to understand some core aspects of geomorphology. Right. So yesterday, whatever we discussed, they are also very important. It's not that you can't leave them. They are also very important, which plays an important perspectives in understanding climatology, like variations in the days, seasons, and all. So once you are good in the basics, then other things becomes very easy. Right. Now, we'll try to understand something about the geomorphic process. Geomorphic process, right? So geomorphic process is also referred as earth movement. Is also referred as earth movement. Now, after this, we will move on to earthquake and some idea about volcanic activities and some rough idea about tsunamis. So basics which are important for your prelims perspectives and which will help you to understand reading other aspects as well. Right. Now, the moment when we say geomorphic process, it includes two forces, what I told yesterday, endogenetic force and exogenetic forces. And this geomorphic process is always associated with deformation of the earth. What do you mean by deformation? Changing landforms. Mountain is replaced by plateau, plateau is replaced by plain. It is not creating new landform, changing one landform into another. It is something like this. You are having a table and from table you have created something different. So we refer that as deformation. It is not creating new landform, changing one landform to another landform. So this geomorphic process always talks about deformation of the earth. Changing the landforms. And this deformation is spontaneous, that is by itself, and gradual process. So this deformation is spontaneous and it is gradual process. So these are the key terms which you should remember. And this is also referred as earth movement or geomorphic process, which includes endogenetic force, exogenetic force, both simultaneously act, and they are responsible for changing one landform into another landform. We refer that as deformation. And this deformation process is spontaneous by itself and also gradual process. It takes millions of years to take. And this is referred as geomorphic process. Is it clear? Now we'll try to decode that. This geomorphic process includes two forces. One is referred as endogenetic forces and second one is exogenetic forces. Exogenetic forces. Now, endogenetic forces are the forces which operate inside the earth. Inside the earth. Right. And here, when we talk about endogenetic forces, it is the heat which is there in the earth's interior. Yesterday, I told three major sources of the heat. Since from beginning, radioactivity and sinking of the denser elements. This heat is responsible for the convection currents in which part of the earth? Convection currents in the asthenosphere. And this asthenosphere, which is beneath the lithosphere, is responsible for the movement of lithospheric plates. And we refer that as plate tectonics. Plate tectonics. So heat generated, plate tectonics, all are referred as endogenetic forces. Endogenetic forces. Heat generated, plate tectonics, right, are there. Now, how do we classify endogenetic forces? Again, these endogenetic forces are subdivided into two major categories. Some of the forces are very sudden in the nature. Some of the forces which are very sudden in the nature. And we refer them as catastrophic. Example, earthquake. Example, earthquake. Catastrophic. And the second type of force is referred as diastrophism. Diastrophism. And this is comparatively very slow process. Diastrophism is very slow process. And this diastrophism again is subdivided into two parts. That is, when the forces are responsible for the movement. Now, two types of movements can be feasible. One is vertical movement and second one is horizontal movement. Vertical movement and horizontal movement. So hence in this diastrophism also, we have two subdivisions. One is referred as epirogenic force. Epirogenic force. And second one is orogenic force. Orogenic force. Now here you should remember, orogeny. What do you mean by orogeny? Orogeny. Orogeny means mountains. Orogenic, mountains. So orogenic forces are mountain building forces. Mountain building forces. Right. Epirogenic are continent building process. Continent building process. Continent building process. So we have orogenic force and we have epirogenic, which are classified as diastrophism. Which one? The theory explains these parts. So continental drift is a theory which explains these forces. So here continent formation means some areas we find something new land is created, the land is submerged. So we refer that as epirogenic and orogenic, right? Now we'll try to understand epirogenic and orogenic bit more so that it will become more clear. Up to this, is it clear now? So in endogenetic diastrophism, which includes epirogenic and orogenic. And the other one is sudden earthquake is an example. Now we'll try to understand epirogenic and orogenic, which will make more clarity. So under diastrophism, we are having epirogenic and we are having orogenic, right? Now, the moment when you talk about orogenic, it is horizontal movement, horizontal movement. Something like this, horizontal movement, right? And epirogenic means vertical movement. Epirogenic forces will always make vertical movement. It means either moving down or either moving upward. Epirogenic. Now, it is something like this. If you are having earth like this, and this portion is the diameter of the earth, if we are talking about vertical forces, the force may push a land away from the surface, or it can push the land inside the earth. So hence, this epirogenic forces is always acting along the radius of the earth. Epirogenic forces, it always acts along the radius of earth. It acts along the radius of earth. Right. So if this is an earth, this is the radius. This is an earth, this is an radius. Now if acts along the radius, sometimes it can push the roof upper side, or it can push the roof or bring the roof downward side. So it always acts along the radius of the earth. And hence, These forces are referred as radial forces. Radial forces. And examples of this are, in many areas we find the raised beaches are there. The beaches which were at the level, they have been uplifted because of pushing outside. So if the forces are acting away from the radius, then it will create uplifting of the landform. Example, raised beaches. Raised beaches. So land and water bodies were at same level. Because of pushing away from the radius, this land got uplifted. We refer that as raised beaches as an example of epirogenic force. Now in the same way, it can be acting towards the radius. When it is acting towards the radius, this land will submerge, this area will submerge, right? And that we refer that as subsistence. Many flourishing ports were there which were operating during the ancient history, medieval history, but now they are submerged in the water. Take an example of Dwarka, submerged city. Andaman Nicobar Islands, they have become as an island because that land which was connecting from Himalayas has submerged. So we refer them as the epirogenic forces. So if it is towards the radius, then it will give subsistence. Subsistence. Example, submerged ports. Submerged ports. Right. So remember that epirogenic force is a radial force. It is vertical. It can be either upliftment or subsistence, upside or downward. And raised beaches, submerged ports. And it is continent formation force. Continent formation force. The orogenic forces are the forces which are referred as mountain building forces. Mountain building forces. Orogeny, mountain building process. And these forces are always horizontal. So it means that they are tangential. If you take a circle, from outside it is touching. Tangential. So these are radial forces. Orogeny or orogenic forces, they are tangential forces. Tangential forces, horizontal. Now, if they are acting towards each other, then that can create compression. We refer this as compression. And compression creates bending of the rocks. And in geography, bending of the rocks is referred as folds. Folds. So this creates folds. Bending of the rock. Generally. Now, when the forces are acting away from each other, we refer that as tensional force. Tensional force. And this tensional force is responsible for creating fissures, cracks, joints, faults. So tension creates joints, faults, etc. Right. So these are the two forces which have been core of geomorphology. So one is horizontal force and one is vertical force, and that is what we study in entire geomorphology. One is mountain building and one is continent building. Is it clear? No. Fold and fall. Now fold. Example of fold mountain is Himalayas. Rockies, Andes, Alps. So they all are fold mountains. Now, example of this faults, we have block mountains. Example of this is block mountain. And the best example of block mountain is Western Ghats. Best example of block mountain is Western Ghats. Faults. Up to this, is it clear? No. Epirogenic and orogenic. Now, folds means it is a result of compression. Compression. Now, as the forces are not having same type of magnitude, and the composition of rock is also not uniform, so hence we have different types of folds are there. We classify them as symmetric fold and asymmetric fold. It is something like this. You are having an aluminum sheet, iron sheet, cloth, and if you put pressure from both the side, the folds will not be same because the resistance are different, magnitudes are different, and the impact is also different. So hence, we are having different types of folds. Generally, we classify them as symmetric folds and asymmetric folds. Asymmetric fold, right? So different types will be there, but more concern is about the faults. More concern is about the faults. Himalayas are complex asymmetrical folds, right? Now, in the context of folds, the upper portion is referred as anticline and the lower portion is referred as syncline. Syncline. So when the rock, if you take rock, if this is a rock, now when this rock is applied a pressure, we refer that as compression. So this rock will bend something like this. So this portion is referred as anticline. And this portion is referred as syncline. Anticline and synclines. Is that clear now? Now, in the context of bends, when we see, if any elevated areas are having the angles which are higher values, say 60 degrees, 80 degrees, etc., we refer them as steep slopes. We refer them as steep slopes. And always remember, steep slopes are vulnerable for erosion, soil erosion. So they will always have the problem of soil erosion. And they will be having thick soil or thin soil. Thin soil, no thick soil, thin soil. Right? And if the angle is very small, then we refer that as gentle slopes. Gentle slope. If the dip angle is, this is called as dip angle. This is called as dip angle. If the dip angle is 0 degrees, if the dip angle is 0 degrees, then we say this as a plane, northern plane. If the dip angle is 0, then we say it is northern plane or plain areas. So gentle slopes are suitable for settlements, agriculture, because they have less amount of soil erosion and they generally have thick soil deposits there. Like some plateaus, some mountains, they have gentle slopes. Is it clear now? So this is some rough idea about the folds. Right. Now, faults are associated with some significant aspect. Remember, all the folds are results of compression. All the folds are results of compression. All the folds are compression. Only compression can create the folds. Now, tension. Understand this. We have the terms called as fault, joint, right, fissure. Understand this bit more. Joint, fissure, fault, cracks, etc. Now, if this is a big rock here, right? Now, maybe because of some pressure, it develops a crack here. And this crack enlarges. This crack enlarges with many orientation. And then it will become a fissure. So generally we say fissure is nothing but crack in the rocks. Fissure is nothing but a crack in the rock, big crack in the rock. So we refer that as a crack. Now, this increases in its orientation. Many fissures with the same orientation, which exceeds and breaks the rocks completely. And this rock is broken into two sides, A and B. So, fissures with many orientation will break the rock. When the rock breaks into two parts, without displacement, A and B are not displaced. We refer that as joint. A and B are not displaced. They are just broken and they are still attached. They are still attached. We refer that as joint. So, two parts without displacement. Without displacement. Right. Now, if two sides makes displacement with each other, then we refer that as faults. If they make displacement, if A and B, if they make displacement with each other, then we refer that as fault. So during the earthquake, we say fault is created. It means the rocks breaks and also displaces. So is it clear now the difference between joint and fault? Now here the displacement may be of two types. It can be vertical or it can be horizontal. So it can be vertical. Sometimes A can move up or B can move down. We refer that as vertical. Or sometimes A can move in this side and B can move on other side. We refer that as horizontal. We refer that as horizontal. Right. So generally we say faults can be vertical, faults can be horizontal. Is it clear now the difference between joint and the fault? Is it clear? No. These terms have, or these perspectives have certain names which are relevant in the context of study of earthquake and study of landforms. Okay, now understand this. If this is a rock strata, because of the compression, it can create bend, right? Or sometimes if you take a rock, because of the tensional forces, it can create the joint or the fault. So it has broken into three rock stratas, A, B, and C, joints. Right. Now here compression, bend is a result of compression. Or we refer that as fold is a result of compression. Now tensional forces are away from each other. Now, as the joints increases, there is possibility that A and C can be stable and B can fall down, right? So here A is stable, C is stable, and B has fallen down. Vertical movement. And such faults are referred as normal faults. So tension will create normal faults. Tension will create normal faults. Up to this, is it clear now? Okay. Now, when there is displacement is done in such way, this stable portion is referred as block mountain or host. Stable portion. We refer this as block mountain or host. And the one which has slipped downward is referred as graben or rift valley. Narmada flowing in the rift valley. Tapi flowing in the rift valley. So this area is referred as graben or rift valley. Rift valley. Is it clear now? Now, if you see this, take this as a part of India, right? Now here, in the context of India, this was a big rock in India. Now, because of tensional forces, this portion broke away. And this portion got submerged. This is western part and this is eastern part. Western part got submerged and this portion got uplifted. This got uplifted. It is something like this. You are having a rock, it has broken, this has moved downward and this has got uplifted. It is something like this. You are having this as a slab. Now this portion has submerged and this portion has uplifted. This is Western Ghats. Is that clear? And hence Western Ghat is referred as block mountain or host. Western Ghat is a block mountain or host. Is that clear? So this portion got uplifted and this is how the Western Ghats looks like. Is it clear? Now, which side of Western Ghat is having steep slopes and which side is having gentle slopes? Where you are having steep slopes, where you are having steep slopes? In the eastern side, you are having gentle slopes. And in the western side, you are having steep slopes. Which rivers are longer, east flowing rivers or west flowing rivers? That's how you have to understand. So Western Ghat is geologically a block mountain. It is a host which is created by this action. Is that clear? And such faults we refer them as normal fault. And as Western Ghats separate west from eastern, so any elevated area with steep part which separates one region from another part is also referred as escarpment. So hence Western Ghat is referred as Great Escarpment of India. The term you remember. So Western Ghat is referred as Great Escarpment of India. Escarpment of India. Now Western Ghat separates the rivers. One is west flowing and one is east flowing. Do you agree with this? It makes rivers east flowing and west flowing. So here we find Kaveri, Krishna, Godavari which are flowing in the east side and west flowing rivers are also there. So hence Western Ghat which separates the two rivers is also referred as water divide. It is referred as water divide. Is that clear now? This is some rough idea about the faults. Now, when we talk about these, if you take the rivers of India, Narmada and Tapi, they are flowing in the rift valleys. Narmada and Tapi are flowing in the rift valleys. In between that, you are having elevated portion, which is a block mountain. And which is that mountain? Satpura. Satpura mountain. So Satpura is a fold mountain or block mountain? Block mountain. So here you are having Satpura. You are having Satpura. And this Satpura is block mountain. Is that clear now? Western Ghat is a block mountain. Satpura is a block mountain. Eastern Ghat, fold mountain. Himalayas, fold mountains. Is that clear now? Normal faults. Right. Now, moving down to this portion. Okay. Now, if you take aluminum scale and plastic scale, if you put pressure from both the sides, the response of both the scales, will it be same? No. Aluminum will bend, whereas plastic scale will break. Now, in the same way, there are certain rocks whose resistance are very strong. They can bend. There are some rocks whose composition may not be feasible. They break. They break. Now, when we talk about the folds, 100% folds are created by compression. Now, this tension creates the faults which are referred as the normal faults. So around 80 to 90% of the faults are normal faults. Not all the faults are created by tensional forces. Sometimes when the compressional forces are there, these rocks will break and they climb each other. They climb each other. So it is something like this. So this portion and this is the rock strata. This climbs and this also climbs on other side. It climbs. And this types of compressional forces, when the rock breaks and makes vertical movement and moves upward, we refer that as reverse faults. We refer that as reverse faults. Reverse faults. Now, reverse faults are the results of tension or compression. Compression. So, reverse faults are the results of compression. So, when you are marking statements, remember, all the faults are created by tensional only. Is the statement correct? No. All the faults are created by compression. Is the statement correct? Yes. Is that clear now? So, this is what you have to understand. Tension, faults, compression, and other things. Up to this, is it clear now? So, this is where we find deep earthquakes occur, the subduction regions, etc. Now, we also have horizontal movements. Now, when the plates make horizontal movement, this is a rock strata, it has broken. Now, this portion move in this direction, this portion may move in other direction. So, when they make horizontal movement, like San Andreas fault, we refer that as strike slip faults. When they make sidewise movement, we refer that as strike slip fault. Horizontal movement, strike slip fault. Now, example of this is San Andreas fault. Now, where do you find San Andreas fault? In North America, near California, you are having that San Andreas fault. Right. So here you are having San Andreas fault, which is associated with major earthquakes, right? And recently, the Turkey earthquake is strike slip one. Not only that, 28th March, Myanmar earthquake is also strike slip. The last week earthquake is also strike slip earthquake. Always remember, when they make horizontal movement, so they will always create shallow focus earthquake. They will always create shallow focus earthquake or shallow earthquake. I'll explain what is shallow earthquake. Remember, is that clear now? So when you are reading, you should remember normal fault, reverse fault, thrust faults, and this is called as strike fault. Now thrust faults means in Himalayas we find where one rock climbs another with lower angle lesser than 45 degrees. We refer that as thrust fault. If this is a rock strata, this has broken and this rock climbs over the other. This rock climbs over the other with lower angle. It climbs on other with lower angle. Lower angle means less than 45 degrees. Less than 45 degrees. We refer that as thrust fault. Thrust fault. Himalayas are having thrust faults. Is that clear now? Thrust faults, reverse faults, normal faults. So when you are reading, when you are marking the statements, you should remember this, right? Now we'll move on to understand the other aspect. So these all are referred as endogenetic forces, which includes epirogenic and orogenic. Is it clear now? So when we discuss, this is how epirogenic and orogenic. Epirogenic is continent formation, orogenic is mountain formation. Is it clear now? Now something about exogenetic force, and then we will move on to earthquake. Exogenetic forces. Now exogenetic forces is the force which is operating outside the earth. And the process involved in the exogenetic force or exogenetic is, the first aspect is weathering. Weathering means breaking the big rock stratas. The second aspect is whatever is broken is transported. So it includes transportation, and sometimes when bulk of the broken rocks are moving downward, we refer that as mass wasting. Mass wasting. So transportation and mass wasting. And the third process is deposition. So hence, exogenetic forces operates with weathering, transportation and mass wasting, and deposition. So big areas are broken, transported and deposited in the lowland area. So it means it does the leveling of topography. So the major idea of exogenetic force is leveling of topography. Leveling of topography. And as it includes erosion as well as deposition. It is also referred as denudation. Erosion as well as deposition. So it is referred as denudation. Denudation. Is it clear? So hence, in the process of exogenetic forces, we always talk about weathering of the rocks. And this weathering includes physical weathering or mechanical weathering. It includes chemical weathering, perfect, and biological weathering. Biological weathering. And it also includes agents of denudation. Rather than erosion, you should use agents of denudation. So it includes agents of denudation. And in the agents of denudation, it consists of rivers, it consists of wind, it consists of glacier, and it consists of groundwater, and it consists of waves, sea waves or ocean waves. Now, if you see them thoroughly, river, wind, and glacier agents of denudation. So they are controlled by climate, rainfall, high velocity wind, low velocity wind. So these three agents of denudations are controlled by climatic factor. Climatic factor. Whereas the groundwater and waves, they depend on regional rocks, region, hard rock, soft rock, nature of the rocks. So they depend on regional lithology, regional rocks. Rocks means lithology. Right. Whether it is hard rock, soft rock, because hard rock will resist, soft rock will disintegrate faster. So hence, among all these 5 agents of denudation, 3 are controlled by climate and 2 are controlled by regional topography, that is the nature of the rock strata. Is that clear now? So this entire process is referred as geomorphic process, which includes endogenetic as well as exogenetic forces. Is it clear now? Now, these, when they operate, they will create erosional landform and depositional landform, which can be significant for your objective types. 5 agents of denudations which have been given in the context of your studies. Is it clear now? So this entire process is referred as geomorphic process. Right. Okay, so now we move on to earthquake and other aspects. Right, so when you are making your notes, yes, please. Chemical? I'll be discussing that. I've given you the chart. I'll be discussing that. Right, so in the weathering, I'll be discussing that. Okay. Now something about earthquake and seismic waves. Earthquake. Now, in a very simple term, earthquake is referred as vibrations on the surface of an earth or jolts, sudden vibration or jolts. Sudden vibration or jolts. Right. Generally, when the plates moves, at the margins of the plates, they will always accumulate stress because of convergence or divergence. If 2 plates are converging, huge amount of stress is accumulated here. And this stress, when it is beyond the limit, it is released in the form of earthquake. So it is the sudden vibrations or jolts because of the sudden release of the stress. Sudden release of stress, which is generated at the boundaries of the plate. At the boundaries of the plate, or sudden release of energy. And this energy which is released, we refer that as seismic waves. So the energy which is released, the waves, we refer them as seismic waves. So this energy is always in the form of waves. We refer that as seismic wave. So hence, the study of earthquake is referred as seismology. The study of earthquake is seismology. And we always say that this energy which is stored is suddenly released. It is nothing but demonstration of, see, you are having a tank above the building. The water which is stored in the tank is referred as potential energy or kinetic energy. When it is allowed to flow downward, here also it demonstrates the conversion of potential energy into kinetic energy. So it demonstrates the sudden release of potential energy into kinetic energy. Is it clear? So sudden vibrations, boundaries. So hence earthquakes are always associated, or we say 99% of the earthquakes are associated with the boundaries or margins of the lithospheric plates. So they are always associated with the boundaries of the lithospheric plate. Lithospheric plates. Is it clear? So 99% you find them. 99% we find them. Lithospheric plates. Is it clear? Now, the terms and other aspects. If this is the surface of an earth, now the energy will release from one point here. And the point from where the energy is released, we refer that as focus. Focus of the earthquake. From where the energy is released. And the point which is exactly above the focus, above the earth's surface, we refer that as epicenter. Epicenter. Another name for focus is hypocenter. Another name for focus is hypocenter. So from the focus, the energy is released. From the focus, the energy is released. And this is the point, and from here, wherever the rocks have broken and they have made either horizontal or vertical movement, we refer that as fault, and that line is referred as fault line. Fault line. So where it has made a displacement, we refer that as fault line. Is that clear now? So focus, epicenter, fault line. And the moment when the earthquake strikes, the energy is released in the form of seismic waves. Seismic waves, right? And these waves are having very typical characteristics. These waves are having certain typical characteristics. Now, before moving down to the nature of the waves, understand the two terms associated with the earthquake: magnitude and intensity. Magnitude and intensity. Magnitude. Now, what is magnitude? Magnitude is energy which is released at the focus. Energy released at the focus. And this magnitude is measured by Richter scale. It is measured by Richter scale. And these values are exponential. What do you mean by exponential? To the power of 10. To the power of 10. So they are exponential. That means if you are taking 3 to the power of 10. And they always have the values range from 1 to 10. 1 to 10. Generally, we say earthquake of magnitude 6 or more. We refer that as major earthquake. Generally, any earthquake of magnitude 6 or more, we refer that as major earthquake. And any earthquake of magnitude 9 and above, Sometimes 8.5 is also taken based on its impact. Major earthquakes. We refer them as mega thrusts. Mega thrust. Right. Now, what is intensity? What is intensity? Intensity is the strength of that energy. Intensity is strength of that energy. And this is associated with losses in terms of injury, death, building collapse, etc. We refer that as intensity. It is something like this. A and B are there. A has slapped B. That is called as magnitude. Now, how hard he has slapped, that is intensity. How hard he has slapped, that is intensity. Right? So, magnitude means energy released. It can be different values. It can be very strong, it can be very less. So it is strength of the energy which is released associated with loss and injury. And this is measured by modified Mercalli scale. Modified Mercalli scale. And it has the values in Roman letters, which is 1 to 12. 1 to 12. 1 means no loss. No loss or very limited loss. 12 means complete destruction. Complete destruction. Like you have an ad called as fog. Right? Sab kuch ud gaya. Right? So only that. It means complete destruction. Thefts, everything will. Roman values. So this is some idea about intensity. So magnitude and intensity are two components of the earthquake. Energy released, and this is the strength of that energy. Is it clear now? Now we'll try to understand body waves and surface waves. Seismic waves, what we say. Right? Now understand. Uh, 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 uh. Uh, uh. Losses are more. See, this is mainly associated with disaster management, where we talk about earthquake resistant buildings, retrofitting. Then we also talk about certain technology which are involved there. So that becomes your part of disaster management. It includes elaborate discussion. So maybe after the class, if you are having doubts, I'll discuss on that. So we talk about technology which are involved there. Like not only there, even in Indonesia, they have developed the technology. Right. So where they use a technology while constructing the building, retrofittings are done, and they generally make such buildings which can resist. We refer them as resilience, which can resist or recover very quickly. Right. So we refer them as code which has to be maintained or norms which are maintained during the construction, sir. So that becomes the preparedness of disaster management. Right. So here just understand the terminology. See, magnitude is referred as the energy released. How much of energy is released is referred as intensity. Intensity talks about damage only. See, it is something like this. A person has slapped somebody. If he has slapped, normally losses will not be there. If he has slapped very hard, then losses will be there, teeth will fall, right? Then chin will break out. So hence, that slapping phenomenon is magnitude. Impact of that is intensity. If it is very hard, losses will be more. See, sometimes when a person slaps as a care and concern, will it have any loss? But when you slap him with full strength, that will be the loss. Is it clear? So the result of energy, the result of magnitude on that object defines the intensity. Is it clear now? Okay. Now we'll try to understand the seismic waves. So seismic waves, we can classify them into two categories: body waves and surface waves. Surface waves. Body waves and surface waves. Now, body waves and surface waves, understand. If this is the focus of an earthquake, after the earthquake, the waves which originates here, in all the directions, inside the earth, within the earth, we refer them as body waves. So these are referred as body waves. So body waves consist of two major categories: P waves or primary waves. P waves or primary waves. Now remember, primary waves are longitudinal waves, like a spring, compression and rarefaction. They are longitudinal in nature. So here we find they vibrate along the medium, straight line. So here they vibrate along the medium, and hence P waves can travel in the solid medium and they can travel in the liquid medium also. In the solid medium, their velocity is very high, somewhere around 11 to 12 kilometers per second. Whereas in the liquid, their velocity decreases. So they reach to, say, around 5 to 6 kilometers per second in the liquid medium. So this is about P waves, primary waves. Now in the same way, another wave is there which we refer them as S wave, secondary wave, S or secondary. So this secondary wave is transverse waves, perpendicular to the medium. Transverse waves. Right. So it moves perpendicular to the medium. Perpendicular to the medium. So hence, it travels only in the solid medium. Only in the solid medium. And its velocity is comparatively lesser than the P waves, somewhere around 6 to 7 kilometers per second. Its velocity is less. Now, the moment when the earthquake takes place here at the focus, at the epicenter, which waves are observed first, P waves or S waves? Which waves will reach to the epicenter, P waves or S waves? P waves, as they travel with high velocities. So at the epicenter, P waves are followed by S waves. After P waves, S waves will reach there. So the first waves which will reach here, P, then the S waves will reach here. Is it clear about the body waves? Now, what happens when they reach to the epicenter? After reaching to the epicenter, they will not come back. Right? After reaching that, part of the energy, part of the body waves, after reaching to the epicenter, starts grazing the surface, start moving the surface. And such waves are referred as surface waves. So hence, after reaching the epicenter, understand, body waves after reaching epicenter, part of body waves is converted into surface waves. So please remember this. Part of the body wave is converted into surface wave. Is that clear? So after reaching to the epicenter, part of the body wave is converted to surface wave. And surface waves are two types, love waves and Rayleigh waves. So there are two types, love waves and Rayleigh wave. Is that clear? And surface waves are associated with destruction. Surface waves are associated with destruction. Is that clear? No. Body waves. So body waves originate from which point? Body waves. And surface waves from epicenter. Is that clear? No. Body waves and surface waves. Right. So body waves consist of primary waves, secondary waves. Part of the body waves convert into surface waves, which includes love waves and Rayleigh waves. Now, why love waves and Rayleigh waves are dangerous? Now, if you see their propagation, if you see their movement, this is how they move. So love waves, they move like snake. So they make sideways movement. Sideways movement, like snakes. Whereas Rayleigh waves are like waves, rolling type. Rolling type. And hence, these two characteristics, sidewise movement and rolling type, is responsible for collapsing of buildings, right? So they make collapsing of building. And these collapsing of buildings creates large amount of debris or stubble, right? Rubble, sorry. They create large amount of rubble or debris. So when the debris fall on the human beings and all, we find deaths, injuries, and economic losses will be there. Is it clear? So this is how the surface waves and their characteristics are associated with the losses. Is that clear? No. Body waves and this is surface waves. Then, so nature of the waves, right? Now, apart from this, you also have to understand one small aspect of the earthquake. Based on the distance between epicenter and focus, based on the distance between epicenter and focus. Epicenter is on the surface and focus is inside. So based on the distance between epicenter and the focus, this distance, earthquakes are divided into three major categories. If the distance between epicenter and focus is less than 60 kilometers, we refer that as shallow earthquake. Shallow earthquake. Example, the Myanmar earthquake, where the distance between epicenter and focus is around 10 kilometers. And these shallow earthquakes are most destructive earthquakes. Most destructive earthquakes because the body waves reach to the surface very fast and the destruction will be very, very strong here. Right. Second, if the distance between the epicenter and focus is 60 to 300 kilometers, then we refer that as intermediate earthquake. Intermediate earthquake. And if the distance between epicenter and focus, if it is 300 to 600 kilometers, average, we refer that as deep focus earthquake. Deep focus earthquake. And In the context of India, we find shallow earthquake and intermediate earthquake. We don't have deep focus earthquake. In Himalayas, we have shallow earthquake and intermediate earthquake. Deep focus earthquakes are generally seen in the area where ocean subduction is seen, like Pacific Ring of Fire. Deep focus earthquake we can find in Pacific Ring of Fire. Is that clear? No. Shallow earthquakes are more dangerous because body waves will take less time to reach to the epicenter and they will be destructive. These will not be much destructive because much of the energy is lost while moving from focus up to the epicenter. Right. Now, hence we say intensity is related with both focus as well as epicenter. If the focus and epicenters are very close, then the intensity will be very high. If the focus and epicenter are at great distance, then the intensity will be very less. So hence we say intensity depends on the distance between epicenter and the focus. And not about magnitude, do not depend on anything. Magnitude is energy which is released. It can be any point, anywhere. It is something like this. Slapping is slapping, whether you are slapping in the classroom or in the market, it is a slapping. But if you are slapping in the classroom, result will be different. If you are slapping in the market, the result will be very, very different there. Is that clear? So hence, magnitude do not depend on anything. Whatever energy is released, maybe it is 8 magnitude, 9 magnitude at shallow, deep. It do not depend on focus and epicenter. The result of that is intensity. So hence, intensity always depends on the distance between epicenter and focus. If they ask, you should remember these things. Is that clear now? Intensity always depends on the distance between epicenter and the focus. And all the earthquakes of magnitude 6, we refer them as major earthquakes. Above 9, mega thrusts. Above 9, mega thrusts. Is it clear now? This portion, earthquake and these. Now, apart from this, we also come across a term which is very much relevant in the context of the earthquake. Understand here. If you take the earthquake of Myanmar, right? So during the earthquake, large amount of energies is released. And this energy is not released in one time. 1 day, 3 days gap, 4 days gap, 10 days gap. So this energy is released in series. Energy is released in series. If you take the data of 2025 March episode of Myanmar, on March 28, the energy released was highest. That is, the energy released during that was 7.7 magnitude. The magnitude of the energy which was released during that, 7.7. After that also, energies were released. Before that also, the energies were released. The highest energy which is released during the earthquake observation, highest energy which is released during the earthquake observation, maybe it is for a month, maybe for a week. Highest energy which is released during that earthquake is referred as main shock. Main shock. So the main shock of the Myanmar earthquake was on March 28, which was 7.7. And all the energies which were released after that, we refer that as aftershock waves. All the energies which were released after that, we refer that as aftershock waves. And hence they recorded that the aftershock waves were having magnitude 3 to 7. They have not crossed 7.7. And all the energy which is released before the main shock, we refer that as foreshock waves. Before the main shock, we refer them as foreshock waves. Foreshock waves. Is that clear now? So earthquake is characterized by main shock, foreshock, and aftershock. Highest energy released, we refer that as main shock. Before foreshock, after aftershocks. Is that clear? So this is what some rough idea associated with Myanmar as well. Is it clear now? Okay. Now, apart from this, we also have certain aspects regarding earthquake. Take an example of the earthquake in the context of India, like Amreli in Gujarat in the year 2023. Amreli in Gujarat in the year 2023. And also in Maharashtra, more specifically Palghar region. Palghar region in Maharashtra, or Greece, more specifically the Satorni Island, or Iceland, recent episodes. So here in these areas, we found that many earthquakes with small magnitude struck in the smaller period of a time. So these geographical areas where we find many earthquakes of small magnitude, without identifiable main shock. Main shock could not be identified here. Without identifiable main shock. So no main shock was identified. And all these earthquakes are of small magnitude, maybe 2, 3, 4, etc. Less than 6, what we say. Small magnitude earthquakes in the smaller area, which affects the small area and in less time. Maybe in Greece, in 2-3 days, 10,000 earthquakes are observed. 130 earthquakes in Iceland. 200 to 400 earthquakes in Amreli in 2 years. Palghar also the same thing. So such earthquakes with less magnitude, without main shock, we refer them as earthquake swarm. Such earthquakes are referred as earthquake swarm. Earthquake swarm. Is that clear now? There is a difference between earthquake and earthquake swarm. In the earthquake, you will have identified main shock, foreshock, and aftershock. In the earthquake swarm, you don't have identified main shock. We refer that as earthquake swarm. Recent examples of earthquake swarm. Palghar in the year 2018. And this is 2025. In Greece, Iceland, etc. Is that clear now? earthquake and these perspectives. Damage will be less here. It may be damages, you can't say, yes, comparatively very less because their magnitude is very less, maybe 3, maybe 4, less damages. But they may indicate a bigger earthquake. It may be a sign of big earthquake. It may be a sign of big earthquake. Is that clear? No. Earthquake and earthquake swarms. I hope it is clear regarding earthquake and all. Now, many earthquakes are there where human beings are involved in creating that earthquakes. We refer them as induced earthquakes. So induced earthquakes are those earthquakes where human beings are involved. Induced earthquakes. Or reason is anthropogenic, man-made factors. Example, construction of dams, mining activities, right? And in US, where they extract shale gas, we refer that as fracking or hydraulic fracturing. Fracking or hydraulic fracturing. Construction of dams, mining, nuclear tests, etc. We refer them as induced earthquake or man-made earthquakes. Induced or man-made. Is that clear? No? Okay. Now, Myanmar earthquake of March 28 is associated with strike slip. It is associated with strike slip fault. Now, what do you mean by strike slip fault? Horizontal movement. So remember this. It is associated with strike slip fault. Horizontal movement, right? And its epicenter was near Mandalay, and Naypyidaw is capital of Myanmar. It is capital of Myanmar. And here 7.7 main shock was observed during March 28, 2025. Is it clear? And remember that when you are reading something, which river or Mandalay is on the bank of which river? So this Mandalay is on the bank, eastern side of Irrawaddy River. Irrawaddy. And Irrawaddy is also associated with dolphin, Irrawaddy dolphin. Irrawaddy dolphin. So in India, we have two types of dolphin species. One is Gangetic dolphin and second one is Irrawaddy dolphin. Gangetic and Irrawaddy dolphin. Is it clear? And the major subduction zone or major fault here, major fault is referred as, just remember the name, Sajaying fault. So this Sajaying fault is responsible for the March 28 earthquake. Fault means displacement. Sajaying fault is associated with the Myanmar earthquake of 2025. Now in the same way, the earthquake of 2004, which created tsunami in India and other areas with a magnitude of 9.2, is also in that area. So this entire stretch is associated with fault lines. Himalayas, fault lines. Faults means the areas where always tectonic activities are there. And it is boundaries of the two plates which are meeting. Eurasian plate and Australian plate or Indian plate, what we say. Two plates, it is boundaries of the two plates. Pacific Ocean, here you are having Indian Ocean. Pacific Plate, Indian Plate. Eurasian Plate, Indian Plate. So it is boundaries of the two, where we always find the major reasons are there. Mega thrust. What do you mean by mega thrust? More than 9. So this Sunda mega thrust is associated with the December 4 earthquake. Sunda mega thrust. This is the Sunda mega. Is that clear? No. So when you're reading, you should remember these points. Now this is a part of main boundary thrust of Himalayas. Main boundary thrust of Himalaya. So when we take Indian geography, I'll explain what is main boundary thrust, what is central thrust, and what is Himalayan frontal fault. So three major faults. When I take Indian geography, while formation of Himalayas, I'll try to explain that portion. Right, so it is something like this. So this is the Himalayas, and this is extension of Himalayas. Extension of Himalayas. Arakan Yoma. Myanmar, Arakan Yoma. And this fault is the Shejeng fault, which was responsible for the recent episode. And this is strike slip, horizontal movement. Strike slip. Same like Turkey earthquake, Anatolian plateau, Anatolian plate of Turkey, some 2 years back, which was there. That is also strike slip. This is also strike slip earthquake. Is that clear? No. Okay. Earthquakes creates faults because that faulting is somewhat energy released. So faults means when the energy is released, and if they are joint, then the energy may not be released. Fault means they should displace, then only the energy is. Right, so earthquake creates the faults. Is it clear? No. All the terms associated with earthquake and the recent phenomenon. Now, India is vulnerable for earthquake. India is vulnerable for earthquake. Right. Now, when we talk about the earthquake belts, three major earthquake belts are there. One is Alpide belt, yesterday I told, which includes Alps and Himalayas. African plate colliding with the Eurasian plate, Indian plate colliding with the Eurasian plate. Alpide belt or Alps belt. Alps Himalayan belt. Second one is Pacific ring of fire. And the third one is in between, wherever dam constructions are there. We refer that as induced earthquakes, means man-made earthquakes. So when you are writing, you should remember, one is the strongest earthquake belt is Alpide belt, which includes Alps and Himalayas. Then Pacific ring of fire. And then we are having induced earthquake. Now, Alpide belt will always have shallow and intermediate earthquake. Only Pacific ring of fire has all the three types of earthquakes, which are referred as shallow, deep, as well as intermediate earthquake. Almost all the earthquakes in India are shallow or intermediate. Nepal earthquakes, Himalayan earthquakes, they are either shallow or intermediate. We don't find deep earthquakes in continent-continent collision. Deep focus earthquake will be there where one oceanic plate has subducted, like Pacific ring of fire. Is it clear now? More part. So that completes something about the disaster, more specifically earthquake. And regarding disaster management, you have to study other parts, how India is divided. So based on seismicity, India is divided into 4 zones. When we talk about Bureau of Indian Standard has classified India into 4 zones. Zone 1 and 2 are in one area. Zone 3, Zone 4 and Zone 5. Zone 5 means entire Himalayan belt and the Bhuj region of Gujarat, extremely vulnerable. Zone 1 and 2 are least vulnerable. Is it clear? So that you will read in the context of disaster management, right? Now, yes. Which one? I'll explain that. I'll explain that. Right. Now, in the context of earthquake, two things were seen here in the Myanmar. Why the losses were more in Myanmar? Among them, one aspect is we refer that as soil liquefaction. Soil liquefaction, which is responsible for huge losses in the Myanmar episode. So what is the soil liquefaction? Understand in a very simple way. Generally, when the buildings are constructed on the soil strata, the soil behaves like a solid structure, which can support the buildings, Now, because of the stress and pressure of the earthquake, due to some amount of water which was accumulated here, right? So this solid nature of the soil started behaving like liquid. Because of stress or pressure, the soil, which is generally referred as solid, start behaving like liquid. Because of pressure and presence of water. Which makes the soil losing its rigidity. And when the soil loses its rigidity, then the collapsing will be more or less. More collapses. So this is one of the reason for huge losses in the Myanmar. Soil liquefaction, where the soil loses its rigidity and collapsing will also be there. That is one reason. Second is that this area, what we refer them as the Mandale. I told this Mandale is on the bank of which river? Irrawaddy River. So it means Irrawaddy River will deposit alluvial soils. So that alluvial soil makes the intensification of the energy there. It means that that is not very rigid soil strata, and hence collapsing will be seen here. So alluvial deposits of Irrawaddy River and soil liquefaction is responsible for huge losses in Myanmar, because alluvial soil is not rigid one. So the energy which is released during the seismic activity intensifies and created huge amount of losses, which do not support large structures of the buildings here. So because of alluvial soils of Irrawaddy and soil liquefaction, we found that the losses were more in the context of Myanmar. In every earthquake, if it is such conditions, even in India also, if any soil liquefaction is there, entire thing will collapse, because that solid structure starts behaving like liquid part. Is it clear? So please remember these two terms associated with the Myanmar as current affairs. Okay. So next we move on to very small aspect of volcanic activity. Only two things you should remember in the context of volcanism, right? In the context of volcanism, right? So volcanism means movement of magma towards the surface. It is movement of magma towards the surface. And when the magma reaches to the surface, we refer that as lava. Solidified magma is referred as lava. And based on the periodicity, all the volcanoes are classified as active volcano, sleeping volcano, dormant, and then dead volcano, extinct one. Extinct means dead one. Now, in the context of India, in Andaman and Nicobar, we are having active and dormant volcano. Active volcano is Barren Island, which erupted in the year 2018. Then dormant volcano, sleeping volcano, is Norkandam. Norkandam is sleeping volcano, which is also in the Andaman and Nicobar. Two volcanoes are there in India. Now they are not erupting. Only one erupting active is there, which is Barren Island. Is that clear now? So based on periodicity, we can classify these volcanoes into three major groups: active volcano, dormant volcano, and extinct, that is dead. Now during the volcanic activity, it emits all the three states. It emits gases like carbon dioxide, sulfur, etc. It emits liquid, that molten magma, which is very hot. And it also emits solid particles. And these solid particles, which are emitted, the rock debris, etc., we refer them as pyroclast or tephra. We refer them as pyroclast or tephra. Solid particles which are released, we refer them as pyroclast or tephra. So all three are emitted or released during the volcanic activity. Now, when you talk about volcanism, the major role is that of the magma. Major role is that of magma. Now, when you read about magma, so more specifically, its composition is significant in understanding the nature of the volcano. Now, in the Earth's upper portion, we always say it is made up of Sial and Sima. It means silica is dominant. So when we talk about magma, silica is taken into consideration, Sial and Sima. So this magma, more specifically, silica is taken into consideration. If any magma is having high silica, if any magma is having high percentage of silica, what happens? If any magma is having low percentage of silica, what happens? If any magma is having high percentage of silica, so it means it is referred as acidic magma. We refer this as acidic magma. Right? And such magmas will be having high viscosity. Such magmas will be having high viscosity. Now, what do you mean by viscosity? What is viscosity? Huh? Resistance? Resistance to the flow of liquids. So if it is having high resistance, will it spread or will it accumulate? High viscosity means high resistance. So here, if it is having high silica, acidic, high viscosity, it means that it will not spread. So why it is not spreading? The reason is it cools and solidifies faster. That's why it will not spread. So high viscosity. So it means it will cool and solidify faster. Solidify faster. So hence, it will not travel for much distance. It will not travel for much distance. So hence, the magma will keep on depositing there. It will create steep mountains like Mount Fujiyama, Elbrus mountains. So it will create steep mountains. Magma will not spread. It will create steep mountains. So that's why volcanic mountains at Ecuador, that is volcanic mountain. Chimborazo is a volcanic mountain, which is referred as highest mountain from the Earth's part. Chimborazo at equator is volcanic mountain. When you compare with the Earth's surface, it is having altitude more than that of Mount Everest. It is volcanic one. Right? Now, if it is having low percentage of silica, then such magmas, we refer them as basic one, and they are having low viscosity. Low viscosity. So when they are having low viscosity, it means they take more time to cool. And as they take more time to cool, the lava will spread. So here they will take more time to cool. So hence the lava will spread. Example, Deccan Trap. Deccan Trap. Deccan Trap has steep slopes or gentle slopes? Gentle slopes. Hawaiian mountains, gentle slopes. Basalt structures. So if they are having low silica, then they will have gentle slopes. Example, the basalt deposits of the Deccan Trap. Deccan Trap. Is it clear? So hence, two ways the magma can be seen. Either it can spread very fast, or either it will accumulate. It is based on silica. If it is having high silica, high viscosity, accumulation. Low silica, low viscosity, spreading. So only two things you should remember. Then, if you are having, say, normal water, and in one bottle you are having, say, champagne or Coke. If you open the lid of normal water and if you open the lid of the Coke or champagne, the impact, will it be same? In the context of normal water, the water will not trigger. But in the context of champagne or Coke, the water will move like a fountain. Why it will move like a fountain? Gas. Simple. Gas. Now, hence, if any volcanic activity, if it is having proportion of gas, it will throw the magma to great height, or else it will not throw the magma to the great height. So what is the role of gas in the volcanic activity? Throwing the magma to the great height. If it is having high gas, high pressure, it can throw the magma to the great height. Is it clear now? So if it is having more proportion of gas, then it means it can throw the magma to great height. It can throw the magma to great height. It means it has high pressure. It means it has high pressure. So hence, based on gas and based on silica, volcanic eruptions can be seen. Is it clear now? Based on silica and based on gas, the volcanic eruption can be seen. Is this part clear now? Now, we'll complete that by merging all the points. If any volcanic eruption is having low silica and low gas, this is one possibility. Low silica and low gas. Second possibility is that it may have low silica and high gas. Second possibility. Third possibility is that it may have high silica and low gas. And fourth possibility is that it may have high silica and high gas composition. So these are the four possibilities where the volcanic eruption can be seen. Now in the first case, where it is having low silica and low gas, as it is having low gas, does the magma throws to the great height? And as it is having low silica, will it accumulate or spread? So we refer that as quiet runaway, like Hawaiian mountains, Deccan Plateau. So we refer this as quiet runaway. Like Hawaiian mountain, Hawaiian eruption. Right. Now, second one is low silica and high gas. Low silica means it will spread. And what is the role of gas? It will make the magma to move upward. And we refer them as fire mountain. Fire mountain. So here the magma will spread and it is thrown to the great height. It will create fire mountain. Example, Stromboli volcano. Now, Stromboli volcano is in Mediterranean Sea, and this Stromboli is referred as lighthouse of Mediterranean Sea. Stromboli is referred as lighthouse of Mediterranean Sea. Lighthouse of Mediterranean Sea. Now, the reason is, what is lighthouse? Generally, during the night, they give the direction for the vessels or ships to reach there. And as it is having high gas proportion, continuously the magma is erupting from the Stromboli volcano. And this gives an identification of the location of places. So the vessels reaches to that area. So hence, Stromboli is a type of volcanic activity which has fire mountain, and it is called as lighthouse of Mediterranean Sea. Is it clear? And then if it is having high silica and low gas, then we refer that as thick and sticky deposits. The magma will not flow. So they create steep mountains, thick and sticky. Thick and sticky. Now, if any volcanoes are having high silica and high gas, so these are the one which are most violent type of volcanoes, explosive type of volcanoes. So these are most violent type of volcanoes. They are explosive type of volcanoes. They always erupts with an explosion. They always erupts with an explosion, because if this is the volcano and this is the vent of volcano, vent means from where the volcano erupts the magma. Now, after the eruption, as it is having high silica, the magma will solidify. So the neck is blocked. The neck is blocked. Now, this volcano also has high gas, so it means pressure is also there. So the pressure is responsible for making the magma to reach it. Now, as the pressure is very high, it will break the neck, and that breaking is creating explosion and the noise. So hence such types of volcanic eruptions which are violent and explosion are always associated with high silica and high gas proportion. Is it clear? So these are the basic things what you should remember in the context of your volcanic part. Clear? Okay. See, here you can get Pelian volcano or Pelian volcano, Vesuvius volcano, which are most violent ones. Now, sometimes when the debris are thrown, they can reach up to 8 kilometers, 9 kilometers, and 20 kilometers also. And the most destructive type of this was in the year 2022. Have you heard about Honga Tonga volcanic eruption? So this is one. So Honga Tonga volcanic eruption. Again, Honga Tonga is in the Pacific Ring of Fire. Now imagine that Honga Tonga volcanic eruption has erupted the dust and ash, and this dust and ash reaches the second layer of Earth's atmosphere. Which is the second layer? Stratosphere. Forget troposphere, it reached to stratosphere. So such huge eruption was there. Is it clear now? So remember, now sometimes when we take the magmas in the oceans or water bodies, when the magma comes in contact with the water, it will always make huge explosion. When magma comes in contact with the water, huge explosion will be there. Now, such type of explosion is referred as phreatic explosion. So please remember this term. When magma comes in contact with the water, so magma is having a temperature of very high, 2000 degrees centigrade, etc. So that temperature convert the water into superheated steam. Suddenly, if you increase 2000 degrees centigrade temperature to the water, then the water will convert itself into superheated steam, and steam will explode, right? So this magma, when it comes in contact with the water, it convert that water into superheated steam. and it will explode. And such explosions, we refer that as phreatic explosion. Please remember this, phreatic explosion. And Hunga-Tunga was phreatic explosion. Hunga-Tunga was phreatic explosion. It was in the ocean, or it is in the ocean, where the magma comes in contact with the water, and that created huge explosion. High gas, phreatic explosion. So that's why the dust and the ash reach to the second layer of the Earth's atmosphere called as stratosphere. Is it clear now? So this is some idea about volcanic activities. Right? So rest, when you're reading, you follow this. Regarding the volcanoes, when you're reading your NCERT books or when you're reading the content, this is more than sufficient. High silica, what happens? Low silica, what happens? High gas, what happens? Low gas, what happens? Is it clear? And the major volcanic belts are, one is Pacific Ring of Fire. Second one is Alphide belt is not volcanic belt. In Alphide belt, you find only earthquakes, no volcanoes. By mistake, don't mention that. Alphide belt or Himalayan Alps belt is only earthquake, no volcanoes. In Himalayas, we find earthquakes, but no volcanoes. So the strong volcanic belts, one is Pacific Ring of Fire. Second one is Mid-Atlantic Ridge. Mid-Atlantic Ridge, right? So Mid-Atlantic Ridge means this area. Don't have the global map here. So Mid-Atlantic Ridge. So where do you find the Mid-Atlantic Ridge? In between the Pacific Ocean and Atlantic Ocean. So that area is called as Mid-Atlantic Ridge, right? Now we'll try to understand some rough idea about tsunami. Very brief. In 5 minutes, we'll try to understand tsunami. After that, you can have a break. Then we can move weathering and other portions, right? Now tsunami. Tsunami is a Japanese term. It is a Japanese term. And it means harbor waves. Harbor waves. It is not single, it is series of waves, not one time, series of waves. Tsunamis are series of waves. And this series of waves, they are responsible for huge displacement of water in the coastal areas. The waves which make huge displacement of water in the coastal areas. Huge displacement of water. Huge displacement of water in the coastal areas. Right? Which makes submergence of the coastal areas. Right? Now, these waves are developed. These waves are developed by many activities. Most of them are due to earthquake. 70% are due to shallow earthquakes. Shallow earthquakes. Then they can be due to huge amount of landslides in the areas. Landslides in the area. Or maybe because of impact of meteorite. Big meteorites reaches there, meteorites, etc. Right? Landslides or glacial subduction. Right? So movement of the thick soil or glaciers in the coastal regions. So these are referred as the reasons for tsunamis. But the major one is earthquake which takes place in the water bodies. Earthquake which takes place in the water bodies. 70% of the tsunamis are because of earthquakes, shallow earthquakes. Remaining maybe because of landslides in the coastal areas or landslide by the volcanic cone, or glacier when it falls in the water bodies, or maybe due to meteoric impact. When they fall, they create the series of waves. We refer that as tsunamis. Now, why tsunamis are dangerous? That is the major thing. Why they are dangerous? There has to be something, right? Now, it is associated with a small phenomenon. Now, this is an ocean, and here you are having ocean water. Ocean water. Now, remember this. This area has struck with the earthquake here. Shallow earthquake of some magnitude has struck in this region. Now, it will develop the waves in the water. So, it will develop the waves in the water, something like this, right? Now, waves means energy which is propagating. Ocean water, waves, currents and tides. The moment when you use the term waves, waves means energy which is propagating in the water. Propagation of energy, we refer that as waves, right? So here, in the context of tsunami, the waves of tsunami waves, the energy of tsunami waves are found in three major components. Three major components. The first one is referred as amplitude, wavelength, and third one is phase of that. Amplitude means height of the wave. Height of the waves. This is called as amplitude. Wavelength means the distance between the crest or the trough. We refer that as wavelength. So if you are taking the distance from here up to this, we refer this as wavelength. Wavelength. Now, amplitude means height of the wave. At least remember these two. Phase means its entire propagation. So the energy of the tsunami waves is confined to three components: amplitude, wavelength, and phase. Now, when this energy is propagating, if there is change in any one component, it does compensatory adjustment itself. Change in any one component. Change in any one component. It make compensatory adjustment. It make compensatory adjustment by itself. It is something like this. You have capacity of eating 10 rotis and 1 bowl of rice. Right, 10 rotis and 1 bowl of rice. So if you have taken 2 rotis, then you will be compensating by eating another 4 bowls of rice. If you have taken 15 rotis, then you may not eat rice. So compensating adjustment you will do. Now in the same way, here also the same process is there. If change in the amplitude is done, then wavelength is affected. If wavelength is changed, then the amplitude is affected. So it makes compensatory adjustment. Is it clear? So this is one. Second thing is, these tsunami waves, they travel with high velocity in deep water. The tsunami waves, they travel with high velocity in deep water, without losing much energy. Without losing much energy. In the deep water, they travel with high velocities without losing much energy. The moment when they reach to the coastal areas where the water is shallow, their velocity decreases. Shallow water. Shallow means less water. If the water is shallow, their velocity decreases. If the water is shallow, their velocity decreases. Up to this, is it clear now? Right. Okay. Now, the last point of discussion, the same process. Now, in the deep water, the tsunami waves are having long wavelength. Long wavelength. So when they're having long wavelength, what about their amplitude? Amplitude will be high or less? So amplitude will be less. So low amplitude. So hence they travel with high velocity without losing much energy. And that's why it is very difficult to identify the tsunami in the beginning stage. You don't find the amplitude. You don't find the amplitude. So they travel with high velocities, with high long wavelength and less amplitude. The moment when the tsunami waves reaches to the coastal areas, so there we find the water becomes shallow. And the moment when the water becomes shallow, their wavelength decreases. So here their wavelength decreases. Now what is compensating adjustment? Amplitude will increase. So wavelength will decrease and the amplitude will increase. Amplitude will increase. And hence they will develop the waves of great heights. And hence they will develop the waves of great height. And this water enters into coastal areas, which brings huge amount of losses. Is that clear? And this phenomenon is referred as shoaling effect. This phenomenon is referred as shoaling effect. Shoaling effect. And hence tsunamis are most dangerous. And after this, the high velocity, high amplitude waves are there. When they hit the coastal areas, all the energy ends up. All the energy ends up. So hence, waves are nothing but they carry the energy. Waves carry energy. Till coastal areas, they will carry energy. The moment when they reach to the coastal areas, all the energy is slapped on the coastal areas. And then the tsunami ends up its journey. Is it clear? So this is why the tsunamis and the waves like that are dangerous. Is that clear? And in the context of India, we have experienced that in the year 2004, subduction zone of that. Right? So you can have a break and then we'll discuss about the other portions, weathering of the rocks and small portion is there. And then we'll take up PYQs, and if you're having any doubts also, we'll discuss that.